Hello everyone. Today we are going to discuss about lowering in the vapor pressure. Lowering in the vapor pressure of what? Solvent. Lowering in vapor pressure of solvent is one of the colligative properties. We have four colligative properties. Relative lowering of vapor pressure, second one elevation in boiling point, and depression in freezing point, and last one osmotic pressure. So we have four colligative properties which depend on the number of solute particles of dilute solution. The dilute solutions will behave as nearly ideal solutions. Therefore, they obey Raoult's law. So, there are four colligative properties of dilute solutions. Among those four, the first one is what? Relative lowering of vapor pressure, or we say lowering in the vapor pressure. Lowering in vapor pressure, we also say what here? Relative lowering of vapor pressure. What I say? RLVP. So, what is the meaning of this? Relative lowering, the full form is relative lowering of vapor pressure of what? Solvent. Relative lowering in vapor pressure of solvent. That is lowering in the vapor pressure of solvent. When a non-volatile solute is added to a solvent, okay, the vapor pressure is lowered. The vapor pressure is decreased due to the following reasons. So first you try to understand what is non-volatile solute here. Non-volatile, so example you take glucose. So generally we take non-volatile solute which neither dissociates nor associates. Here glucose neither dissociates nor associates in water. So the non-volatile solute is added to a solvent. Here it is volatile solvent. What is this one? Volatile solvent. Example you take volatile solvent, water. Water is an example of what? Volatile solvent. Okay. To this water we have added suppose glucose. Non-volatile solute is added to water. Then water vapor pressure will be decreased. The vapor pressure of this water is decreased, lowered due to addition of what? Non-volatile solute. Okay, there will be some reasons for lowering of vapor pressure. The first reason is that percentage surface area occupied by the solvent decreases. If you take pure water, if you take pure water, here pure water has some surface area. Pure H2O has some surface area. Here only the particles of water there. On the surface, only particles of water, no other substances. But if you take the same vessel, to this same vessel, we added some, what here, glucose. Then we got glucose solution, suppose. What we got? Glucose solution. Now, on the surface of glucose solution, the total surface area will remain same now. But here, the water is there, glucose particle there. Water particle there, glucose. Water and glucose. Now, what happened? The percentage of occupied area will be decreased here. Okay. So, the percentage surface area, the percentage of surface area occupied by the solvent molecules will be decreased here. Here, more surface area occupied by solvents, solvent molecules. The solvent molecules occupied more surface area in this case. That's why more vapor pressure here. More vapor pressure for pure solvent. But here in the glucose solution, aqueous solution of glucose, glucose non-volatile solute is added to what? Water. Then what happened now? Solution. This solution has less vapor pressure. This pure solvent has more vapor pressure. The solution has less vapor pressure. Is that clear? Now, what is this here? P naught. P naught is what now here? Vapor pressure of pure solvent. Vapor pressure of pure solvent is what now here? P naught or PA naught. PA or P. PA means solvent. A means solvent here. B for solute generally we take. In a binary solution, the letter A is taken for solvent and B is taken for solute. Otherwise, number 1 is written for solvent, number 2 is written for solute. Here in some books they take P naught, or we also write what? PA naught. PA naught meaning what here? The vapor pressure of pure solvent A. That is vapor pressure of pure solvent. And here what now here in this case? In this case, the vapor pressure of solution. What is here? PS. What we take? PS. PS means what? Vapor pressure of solution. In which case, the solvent molecules occupied more surface area in pure solvent. But in solution, the less number of solvent molecules occupied the surface. That's why the solvent only volatile here. Solute particles are non-volatile. They cannot be coming to vapor phase. That's why only solvent will be evaporated. That's why what happens now here, the solution gets less vapor pressure, whereas the pure solvent gets more vapor pressure. That's why the lowering in vapor pressure, what minus what we have to take? Greater value minus lesser value. Your PA naught is greater and PS is lesser. PS means vapor pressure of solution. PA naught means what? Vapor pressure of pure solvent. Okay, so like this, lowering of vapor pressure is nothing but PA naught minus PS. So first reason why there is lowering of vapor pressure is that the percentage surface area occupied by the solvent decreases. Thus, the rate of evaporation and vapor pressure decrease. The rate of evaporation and vapor pressure, these both properties decrease. Okay, then the solute molecules means in this example glucose molecules. The solute molecules occupy the surface. Okay, the solute molecules occupy the surface, and so the percentage of surface area occupied by the solvent decreases. The percentage surface area occupied by the solvent will decrease here due to presence of what? Solute particles. That's why the solution has lesser vapor pressure than what? Its pure solvent. So this is the reason why the lowering in vapor pressure of solvent takes place when we add a non-volatile solute. Next, second reason why there is lowering of vapor pressure. Second reason is that according to Graham's law of evaporation, like Graham's law of diffusion, it is what now? Graham's law of evaporation. According to Graham's law of evaporation, rate of evaporation of solvent. The rate of evaporation of solvent is directly proportional to what? 1 by square root of density. That means what now? Inversely proportional to under root density. So rate of evaporation is inversely proportional to the square root of density. More the density, lesser will be rate of evaporation. Now, if you add glucose to water, we get solution, glucose solution, which will have more density. Glucose solution has greater density, or pure water has greater density. The glucose solution, aqueous solution of glucose will be having more density. When density is more, the rate of evaporation is less. Okay? So rate of evaporation is inversely proportional to the square root of what? Density. This is what according to Graham's law of evaporation. So when a non-volatile solute, means example what we have taken here, glucose or urea, otherwise sucrose. These three will be ideal. Why we take these three always? These three particles neither dissociate nor associate in the solvent. That's why when non-volatile solute is dissolved in a liquid, when a non-volatile solute is dissolved in a liquid like water, its density increases. The density of water increases. Okay, the solution gets more density than pure water. When density is greater, rate of evaporation, what happens here? Decreases. So thus, both rate of evaporation and vapor pressure are lower. Whenever rate of evaporation is decreased, the speed of evaporation decreases, vapor pressure will be decreased. That's why the lowering in vapor pressure occurs here. The relative lowering of vapor pressure is due to what? The increasing density from solvent to solution conversion. The density will increase. When density increases, the rate of evaporation decreases and vapor pressure decreases. That's why the solution formed as lesser vapor pressure than what? The solvent. And the previous reason what we have discussed here, what is the first reason here? Percentage surface area covered by solvent molecules will be decreased. When solvent converts into solution by adding non-volatile solute, what happens now? The surface area covered by solvent will be decreased. So the surface area in the solution is occupied by both solvent molecules and solute molecules. Whereas in pure solvent, the total surface area is covered by only solvent molecules. That's why more evaporation will be there in pure solvent. When evaporation is greater, automatically vapor pressure will be greater for pure solvent than its solution. Okay. So this is what we are now lowering in vapor pressure. Next, when Non-volatile solute is dissolved in a liquid. A liquid means water you take. So anyhow, rate of evaporation and vapor both will be lowered here when density increases. Next, if P naught is the vapor pressure of pure solvent, P naught is taken as what? Vapor pressure of pure solvent, P naught. And PS is what? The vapor pressure of solution. PS is the vapor pressure of the solution form. The pure solvent vapor pressure is what? P naught. PS is what? PS is the vapor pressure of solution formed. Now the difference P naught minus PS. The difference P naught minus PS is termed as what? P naught minus PS is termed as what? Lowering in vapor pressure. LVP we say. What we say? LVP. Lowering in vapor pressure. And the ratio P naught minus PS by P naught. The lowering in vapor pressure, this one. Lowering in vapor pressure divided by, initially what is this here? The vapor pressure of pure solvent. Vapor pressure of pure solvent. This ratio is called what? Relative lowering in vapor pressure. That is called RLVP. What is called? RLVP. So what is RLVP here? Relative lowering of vapor pressure. Relative lowering in vapor pressure. LVP means P naught minus PS. But P naught minus PS divided by P naught is called what? Relative lowering in vapor pressure. So what is relative lowering of vapor pressure? The ratio of lowering of vapor pressure to the vapor pressure of pure solvent is called relative lowering in vapor pressure, RLVP we say. Okay, next. Raoult, the scientist name. Raoult in 1886 established a relationship between relative lowering in vapor pressure and composition of the solution. Composition of solution and relative lowering in vapor pressure. The relationship was given by Raoult in 1886. After a number of experiments. After a series of experiments, meaning what? After a number of experiments, he has given the relationship between what? RLVP and composition of solution in various solvents. In different solvents, he has conducted experiments. Okay, so from series of experiments, he has established a relationship between what and what? RLVP and composition of solution. The relationship is known as what? Raoult's law. The relationship between what here? The vapor pressure of the liquids and composition of solution. Okay, this relationship is called what? Raoult's law. And Raoult's law states that the relative lowering in vapor pressure, of a dilute solution, the relative lowering of vapor pressure of a dilute solution is equal to mole fraction of the solute. Mole fraction of solute means what here? XCA or XB? XB. XB meaning what here? Number of moles of B solute divided by number of moles of solvent plus number of moles of solute. Okay, what is XB here? Mole fraction of solute. Mole fraction of solute XB is equal to what? Number of moles of solute to the total number of moles of solution, Na plus Nb. This ratio is called what? Mole fraction of solute. Okay, present solution. That means what? What is that here? According to this statement, what? RLVP is equal to mole fraction of solute. RLVP is equal to what? Mole fraction of solute. What is RLVP here? P naught minus PS by P naught. P naught minus PS by P naught is equal to what? XP. Okay, so that is called Raoult's law here. Okay, RLVP means formula what here? This one. RLVP formula is P naught minus PS upon P naught. What is P naught here? P naught is called vapor pressure of pure solvent, and PS is vapor pressure of solution form, and P naught is vapor pressure of pure solvent. This ratio is called what? Relative lowering of vapor pressure. And according to Raoult's law, this relative lowering of vapor pressure is equal to what? XB. XB means what? Mole fraction of solute in the solution. Next, if n number of moles of solute, if n number of moles of solute be dissolved in capital N number of moles of solvent. Here capital N is what? Number of moles of solvent. Number of moles of solvent. In some books it will be taken Na. Na means what? Number of moles of solvent. The same thing is taken here, capital N, number of moles of solvent. And what is small n here? Small n is what? Number of moles of what? Solute. Number of moles of solute. In different books, it will be taken what? Different ways. So a small n is taken number of moles of solute, and the same thing will be taken NB. NB means number of moles of solute. A B stands for solute. A stands for solvent. And in place of NB, in some books, they also take N2. N2 number of moles of solute. And in place of Na, what they take? In place of Na, N1. N1 means number of moles of solvent. N1 or Na represents what? Number of moles of solvent. NB or N2 represents what? Number of moles of solute. But in this book, we have taken what now here? Small n and capital N. Small n is representing what? Number of moles of solute. Capital N representing what? Number of moles of solvent. Okay. So now here, mole fraction of solute. Mole fraction of solute, how to represent? XB or XA? XB. Otherwise, X1 or X2? X2 we take here. XB or X2 is equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent. This is what now here? Total number of moles of solution. Total number of moles of what? Solution. Total number of moles solution. So number of moles of solute to the total number of moles of solution. This ratio is called what? Mole fraction of solute. Okay. Next, according to Raoult's law, what is equal to what? RLVP is equal to XB. What is the relation here? RLVP. RLVP stands for relative lowering in vapor pressure is equal to XB. XB means what? Mole fraction of solute here. So here, see, RLVP this one. P0 minus PS by P0 is called RLVP. What is here? RLVP means what? Relative lowering of vapor pressure. Okay, this is equal to number of moles of solute upon total number of moles of solution. So this is what I call Raoult's law. And this is the mathematical expression for Raoult's law. So it is what now here? Mathematical expression for what now? It is for Raoult's law. Yeah. So this is about what now here? Relative lowering of vapor pressure and Raoult's law. So according to Raoult's law, relative lowering of vapor pressure is equal to mole fraction of solute in the given solution. Okay. Next one, modified form of Raoult's law. Modified form of Raoult's law. Okay. So the above relationship is what now here? P0 minus here P0 minus PS by P0 we wrote in previous case. But now we are writing what here? P0 by P0 minus PS. P0 is what here? Vapor pressure of pure solvent divided by what we have taken? P0 minus PS. The above relationship what we wrote here? Previous equation what we wrote, tell me? Previous equation is what? P0 minus PS by P0 we wrote is equal to XB. XB means what? Tell me generally. XB means what? Number of moles of solute by number of moles of solute plus number of moles of solvent we have taken. This is the previous one. Now the same thing we are writing what in modified form. This is called modified Raoult's law. According to modified Raoult's law, what we take now reverse, we inverse this one. Here P0 minus PS by P0 will be written like P0 upon P0 minus PS is equal to, again this also will be reversed, inverse. So n plus n, small n plus capital N upon small n. Okay, this is equal to 1 plus capital N by small n we can write. 1 plus capital N by small n. So 1 plus capital N upon small n is equal to P0 upon P0 minus PS. So finally what you got here? P0 upon P0 minus PS is equal to 1 plus capital N by small n. Well, this relation. So this is what now here modified form of Raoult's law. Okay. So now a P0 upon P naught minus Ps is equal to, this one we have taken left side here. So P naught upon P naught minus Ps minus 1. This one will be taken this left hand side here. So minus 1 is equal to capital N by small n. Or we take what? Ps upon P naught minus Ps is equal to capital N by small n. Ps upon, Ps means what now? Vapor pressure of solution. Vapor pressure of solution upon P naught minus Ps is equal to capital N divided by small n. The capital N is what? Number of moles of solvent. Small n is what? Number of moles of solute. Is that clear, ma? So it is the number of moles of solvent by number of moles of solute. It is what now here? Weight of, number of moles formula what? Weight of solvent. Given weight of solvent upon gram molecular weight of solvent. Gram molecular weight of solvent. Given weight by gram molecular weight will be number of moles. And small n is what here? Given weight of solute. Given weight of solute upon gram molecular weight of solute. Given weight of solute by gram molecular weight of solute is small n here. Okay. So now what we got? Modified form of Raoult's law here. This formula you have to remember. Ps upon P naught minus Ps is equal to capital N by small n. Okay. The same thing we can write like this here. The same thing we can write P naught minus Ps. Now again we are inverting this one. We are inverting. So P naught minus Ps upon Ps is equal to, here capital N by small n is made into small n by capital N. Okay. So this equation to be applied in numerical problems. It is very important. Okay. So this equation gives accurate results and it is easy to apply here. It will be easy to apply and it will be giving accurate methods, accurate calculations. So now earlier we are using what is equation? What is this here? P naught minus Ps by P naught is equal to Xp. Xp means what here? N upon N plus N. And also remember that the small n value will be very lesser in comparison to capital N for very dilute solutions. For very dilute solutions, small n value will be very less in comparison to capital N. Number of moles of solute will be very less in comparison to number of moles of solvent generally. That's why here small n plus capital N will be nearly equal to what? Capital N only we take. Small n plus capital N will be taken as capital N. That's why here in this case what we take now here? Tell me. In this case, here small n by capital N only we take here. Here small n plus capital N will be taken as capital N. That's why small n by capital N will be equal to P naught minus Ps upon P naught. It is old equation. Tell me what is the original equation? According to Raoult's law, tell me. P naught minus Ps by P naught is equal to small n upon capital N. It is for very dilute solutions. For very dilute solutions. For very dilute solutions, we take this formula, normal formula. But here, we take what now? For concentrated solutions also. Not only for dilute solutions, but also for concentrated solutions, we take this formula. This will be taken as what now here? Accurate formula. Modified formula of Raoult's law. So here P naught minus Ps upon Ps we take here. P naught minus Ps by, again Ps, is equal to small n by capital N. But here old equation is what? P naught minus Ps upon P naught is equal to n by n, small n by capital N. So these two formulas should not be confused here. So whatever you feel that you get it, mostly answers will be near when we use both equations. Okay. So this is what now your relative lowering of vapor pressure. Relative lowering of vapor pressure concept. And next one is here. The same thing. Ps means vapor pressure of solution upon P naught. Ps by P naught is equal to capital N upon small n plus capital N. Okay. And now from this what we can take now here? 1 minus Ps by P naught. 1 minus Ps upon P naught is equal to, okay, 1 minus N upon N plus N. N upon N plus N. Okay. Next, P naught minus Ps by P naught. P naught minus Ps by P naught is equal to small n by total number of moles. Small n by small n plus capital N. This is also Raoult's equation. Okay. So this formula we can use for very dilute solutions. Very dilute solutions in which small n is very less than what? Capital N. Therefore, small n plus capital N is equal to what? Capital N. We take care. But for any type of solution, for even concentrated solutions, what we use? P naught minus Ps by Ps. P naught minus Ps by Ps will be equal to small n by capital N. That is relative lowering of vapor pressure. Okay. Next, if a solution is made by dissolving Wb grams, Wb means weight of solute. Weight of solute. Okay, by dissolving Wb grams of solute with gram molecular weight Mb. So Mb is what now here? Gram molecular weight of solute Mb. And Wa is what now? Weight of solvent. Weight of solvent. Weight of solvent is taken as what? Wa. So Wa grams of solvent with gram molecular weight, how much here? Ma. So gram molecular weight of solvent. Gram molecular weight of solvent is taken as Ma. Okay. So when Wb grams of solute is dissolved in Wa grams of solvent, the mole fraction of the solute means Xb will be what? So Xb is equal to what now here? Xb is mole fraction of solute. Xb is equal to number of moles of solute by number of moles of solvent plus number of moles of solute. It is what now here? Number of moles of what? Solute. Number of moles formula given weight by gram molecular weight. And it is what now here? Number of moles of solvent. Wa by Ma is what? Wa by Ma is what? Number of moles of solvent. Okay, ma? So now number of moles of solute upon total number of moles of solution is called Xb. Is called Xb. Xb is what now here? Mole fraction of solute. If the solution is very dilute, Wb by Mb can be neglected in the what here? Denominator. Means here. In the denominator means what? In the solute number of moles plus solvent number of moles. When you take, which will be very less, solute will be very less number of moles in comparison to number of moles of solvent for very dilute solutions. That's why what we can neglect in the denominator, Wb by Mb we can neglect. Okay. Then the solution becomes what now? RLVP. RLVP means P naught minus Ps by P naught. So RLVP is equal to what now? Weight of solute by gram molecular weight of solute into gram molecular weight of solvent by weight of solvent. So this formula to be applied here. This relationship is useful in the determination of the molecular mass, gram molecular weight of dissolved solute by measuring relative lowering of vapor pressure. By measuring this RLVP, we can calculate what? Molecular weight of solute. Mb we can calculate. Mb is what now? Gram molecular weight of solute. We can calculate. Mostly aqueous solution, if they mention, what will be gram molecular weight of solvent? Gram molecular weight of water. Water means 18 grams per mole. Okay. So like this, we have to understand the concept of what? Relative lowering of vapor pressure. Okay. Bye. Thank you.